define the problem. We looked at the wiki page for the fabric bucket and determined the problem. We are to design and construct a portable and compressible fabric bucket that can hold 1 gallon of water for 1 minute without using commercial or pre-made waterproofing agents such as tarps, plastic films, or duct tape. The bucket must contain at least 50% of a fibrous material in the water storage part of the bucket.
Search for solutions. When searching for solutions to this problem, we first decided to research non-commercial waterproofing agents. We found 3 possible solutions: beeswax and lanolin, soybean oil and turpentine, or petroleum jelly. For the choice in fabric, we decided to choose between polyester and cotton.
Narrow and select. We decided that petroleum jelly would add too much weight to the bucket, and that the beeswax may be too flaky and not cover the entire bucket, so we chose turpentine and soybean oil. We found a recipe online that involved mixing 2.5 ounces of soybean oil and 1.25 ounces of turpentine to create a waterproof mixture. For the fabric, we chose polyester because it is hydrophilic, which meets an extra credit requirement, and is lightweight, which factors into the grading scale.
Build. For the prototype, we cut out a small square of polyester. Then we made the turpentine and soybean oil mixture. We painted the mixture onto the fabric in 3 layers, waiting 48 hours in between each layer so that the turpentine could dry. We then tested this prototype over water to see that it did hold water successfully, yet there was one tiny piece of fabric that we did not fully cover with the waterproofing agent, which caused a tiny bit of water to seep through. We discovered that we had to make sure to fully cover the fabric in our final product if we didn't want to see the same result.
For the final product, we cut out a piece of polyester that was 36 by 24 inches and painted on 5 layers of the waterproofing mixture, still waiting 48 hours in between layers. For the construction of the bucket, we knew that we needed to maximize the strength of the fabric while making sure it is still lightweight. So we chose to limit the amount of seams on the bottom of the bucket by folding over the fabric and sewing seams along the 2 sides of the bucket. After sewing the bucket, we added the waterproofing agent along the seams and let it dry.
Test and check. We tested the final product to see that it successfully held water. We decided to not test a full gallon of water because we did not have enough time to reconstruct the entire bucket if it failed. Instead, we added an extra layer of polyester that had the waterproofing agent painted on it because we had extra fabric. We added this extra layer to the bottom of the bucket to try to reinforce the weakest points of the bucket, the corner seams.
Design challenges. The first challenge we faced was the craft center closing when we needed to sew the bucket, so we had to sew by hand. However, the seams ended up being successful because we had time to waterproof them. The second challenge we faced was trying to limit the amount of seams at the bottom of the bucket. To do this, we folded the fabric so there were no seams at the bottom, and only had seams going up each side of the bucket and seams that attached to the handles. The third challenge we faced was that the turpentine had not completely dried when we needed to sew the bucket, so we had to use a hair dryer to fully dry the bucket. Finally, we ran out of time at the end, so we could not test a full gallon of water.
Yeah, go for it. He's gonna time you. You just have to start it now, right? Yep. We got a sieve here. I don't think it's...
For our fabric bucket, all of the requirements and constraints were met. Because of its small size and because we used light fabric, the bucket easily fit inside the 4 by 4 by 6 inch box. The bucket was also less than 24 inches in height, as it reached about 18 inches after adding the handles. There was at least 50% fibrous material in the bucket, as the entire water storage area of the bucket was made out of polyester. The bucket did not include any pre-made or commercial waterproofing agents. However, our bucket did not hold 1 gallon of water, so we were disqualified from the competition. How did your project fare in competition at FEDD? Our fabric bucket did not succeed at competition. Water started leaking through the fabric after about 15 seconds.
What we would do differently. First, we would use thicker fabric. We were not aware of every possible fabric that we could use. It would be useful to discuss possible fabrics with the project guru. Last, we would start the prototype earlier, so we have more time to add additional support if there is leakage and to test the final product completely.
Advice for next year. Talk to the project guru before picking a fabric. Start early and make more than one prototype. Pay attention to the hours of the craft center near Thanksgiving break. Pay attention to all of the extra credit opportunities, and make sure you have time to waterproof the seams. Lastly, we would advise beginning to research the project as early as possible. Try to research individually, then meet as a group and compare your findings. We researched for our project together, which likely limited our findings.